The final topic we're going to be covering in this unit is graphic representations. So this topic, we're just going to be looking at different ways to interpret graphs and talk about them. So to start off at the top here, let's just try these right here. Which type of graph would you use to show each of these? So let's start off with part one here, the part of the tourism industry for camping. So let's think of the wording here. It says the part of the tourism industry for camping. Whenever we're thinking of a part of a whole, so in this case, the whole would be the tourism industry, and the part of it would be the camping. Every time we're comparing a part to a whole, we want to use a circle graph. Circle graphs easily allow us to see visually how much a part is of the entire whole. In number 2 here, it says the number of people who receive employment insurance in each province and territory. So for that one there, I would just go with a basic bar graph. This would easily allow us to put all the provinces and territories on the horizontal axis of the graph, so that's down here. And then alongside this axis here, we would have how many people receive employment insurance. And then we could easily see how tall each bar is. And finally, number 3 here, it says the wages someone earns over an 8-hour shift. Now, whenever I see time involved in a graph, I automatically think to use a line graph. And the reason for that is time is a continuous thing. It is constantly going. So when we are using a line graph, all of the points that we put on our graph are connected. And that represents a continuous variable, something that is always going and never stopping, which is time. Now let's look at these graphic representation questions. Zach created 2 graphic representations to show the number of used cars on his lot. What decisions should Zach make? Justify your choices. So here we have 2 graphs. They're pretty similar. They're showing us both the same information, except in one of them, this one over here, he grouped the ranges to be larger. So it goes from 0 to 6,000, and then 6,000 to 12,000, and 12,000 to 18,000. So each of these ranges is a $6,000 interval. But if we're looking in the graph next to it, our intervals are smaller, right? In between each interval is only $2,000. So number 1 says, which graphic representation should Zach use to show he has many cars in the mid-price range? So if I were Zach and I was just showing how many cars we have in the mid-price range, I would go with the first graph. And the reason for that is because it shows a high bar in the middle price range. And the bar I am talking about is the one right over here. That would be, we would have the lower price range over here and the higher one over here. So right in the middle, you can see that that bar is the highest. Therefore, he has many cars in the mid-price range. In number 2, it says, which one should Zach use to show he has cars in many price ranges? So if I were Zach and I wanted to show that I have cars spanning all the price ranges, I would choose the second graph. And that's because it shows more ranges. So if I'm looking at the second graph, I could see, oh cool, Zach has cars in the $2,000 to $4,000 price range. He also has some in the $10,000 to $12,000 price range, the $6,000 to $8,000, and so on. When I'm looking at this first graph here, we can kind of see the same thing, just not with as much detail. So for number 2, I would go with the second graph. And finally, the last question says, which one should he choose to show a buyer he has several cars in each price range? So for this one here, I mean, both graphs show us that he has several cars in all of the price ranges. So I would say either graph works for this one. They both show the frequency, and what I mean by the frequency is how many cars he has in each price range. So let's scroll down to number 3 here. It says, suppose you want to buy a car from Zach. What information is missing from these graphic representations? So if I was looking at these graphic representations here and I wanted to buy a car from Zach, I would be curious about the exact price of a car because all of these ones just show us price ranges. They don't actually pinpoint the exact price of any car. So for number 3, we're going to put the exact price of any car. Now you might notice something else missing from these graphs here, like maybe the make and model of cars as well. That's something you could also put for number 3. And finally, in 4, it says Zach says that half of the cars cost less than $10,000. Do you agree? Why or why not? So let's look at our graph and see if we have half the cars costing less than $10,000. So for this one, I am going to use the second graph here because it shows us exactly how many cars are under the $10,000 mark. If we used the first graph, the $10,000 mark would be in the middle here. So it's hard for us to split up that bar into 2, knowing how many are below 10,000 and how many are above it to 12,000 here. So I'm going to use the second graph. So let's look at our frequency for each of these bars. If I'm looking at this first bar here, the frequency of that one I would say is about 4. Then the second bar, I'd say that frequency is 8. For the third bar, I'd say that is 16. And for the fourth bar, I would say that is 28. So if we add up all those numbers, 4 plus 8 plus 16 plus 28, we get approximately 56 cars for that frequency of the first 4 bars. Now let's add up the last 4 bars and see if we have more or less in our frequency. So let's start with this one here. I would say that's landing right on the 15 mark. Then the next one I would say is right on the 20 mark for sure. The next one here, that's just above that bar, so I would say that's 6. And then finally over here, I'd say this one is 3. So let's add up all these numbers. 15 plus 20 plus 6 plus 3. And if we add all those together, we're going to get 44 cars. So the first 4 bars are all of them that are under $10,000 adds up to 56. And then all of them that are above $10,000 adds up to 44. So I would say more than half of them are under $10,000. So for this question here, I would put yes. More than half of the cars are less than $10,000. And this is because if we add up the frequencies of the first 4 bars, it is greater than the last 4. And there we have it for that question. Now let's move on to the next example. An ad for an alarm security company showed this information about property crimes in their province during a recent year. So the ad is just over here. Let's take a look at it. At the top it says, the majority of property crimes are theft related. Are you protected? So they give us this graph here, which is simulating a circle graph, even though they're using a stop sign shape. It's like an octagon, right? Has 8 sides. So they're representing this data in a circle graph. So let's see. So for number 1, it says Roxanne works at the company. She agrees with the ad. Explain why her conclusion is reasonable. So this ad is stating that the majority of property crimes are theft related. Let's look at these examples of property crimes and which ones are theft related. So theft, that includes a few things. That includes, obviously, theft. That includes break and enter. If you break and enter somewhere, you're probably stealing something, so we'll include those in it. And that'll also include the possession of stolen goods. So that's what I'm kind of ticking off here in the solution part A. Now to help us with this question, what I'm going to do is I'm going to divide this stop sign into segments of 16ths because that's how we're going to answer this question. Now this is a weird question. I won't give you one like this, but bear with me here. So I'm going to break this up into segments of 16. And that's just to help us because we're dealing with the stop sign shape. It's to help us kind of see how many lie in each part. All right, so I tried to make my lines as straight as possible here, and I divided the stop sign up into 16 segments to help us with the next part of this question. And like I said, I will usually give you the percent of each segment, but for this question they didn't, so we need to find a way to work around it. So this is kind of a little solution. So You'll notice we have 16 segments, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So let's look at the fractions for crimes related to theft. So this first one here, theft itself, let's count how many segments of the 16ths we have. And they do give us the answer here, 7 out of 16, but let's confirm that. So theft, it's like this light shaded gray. So it would be this whole kind of section over here. So if we count the segments, we have 1, 2, 3, 4, 5, 6, 7. So that's where they get that 7/16 from over here. Break and enter. If we look at that, those are the ones with the lines in it. So that would be here. And if we count those segments, it's 1, 2, 3. So that's how they get 3/16 here. And finally, possession of stolen goods. I noticed that the booklet actually has the wrong answer here. So for the possession of stolen goods, we're actually looking at this segment right here, and that would only be 1/16 of our graph. So the booklet is wrong here. That is only one little segment, or 1/16. So the total here is we would add all of these fractions up. We have 7/16 plus 3/16 and plus 1/16. And if we add all those up, that leaves us with 11/16. Now, usually these wouldn't be fractions, these would be percentages. But for this question here, let's deal with the fractions. So the fraction of theft-related crimes is 11/16. Or in other words, if we convert that to a decimal, we're going to do 11 divided by 16 in our calculator. 11 divided by 16, and that equals 0.6875. And if we multiply that number by 100, we will get our percent, which would be 68.75%. Now let's look at part B. Tyler wonders which crimes against property the police deal with the majority of the time. Complete the statement below. The percent of theft-related crimes is about blank percent of the property crimes. So if we're just looking at the theft ones, that was 7/16. And if we convert that to a percent, we would do 7 divided by 16 in our calculator, which would give us, so we would do 7 divided by 16. That gives us 0.4375. And if we times that by 100, we would have 43.75%, or if you round up, 44%. So 44% of the property crimes are theft related. Now the percent for the other crimes, well, all the other ones we're just going to do 100 minus this 43.75%, and we will be left with the percentage of all the other crimes. So 100 minus 43.75, that gives us 56.25%. So all the other crimes account for 56.25% of the property crimes. Therefore, the police deal with the other categories most of the time. Now that being said, theft itself is a huge percentage of the crimes. All these other types of crimes here don't happen as frequently as purely theft crimes do, but when we add up the totals of all these ones I just put in green here, it'll equal more than just the theft ones alone.